Welcome to Study Loop.
Okay, guys, we're going to be doing question number 40 in Chapter 5 of Chemistry to Central Science. We're going to be looking at the decomposition of calcium hydroxide into calcium oxide and water. So we're adding 109 kilojoules of heat to produce this decomposition process. First, we're going to balance our equation. So we have one calcium on the left side, one calcium on the right side. So now we have two hydrogens on the right and two hydrogens on the left. And we have two oxygens on the left and two oxygens on the right. So this is perfectly balanced right now. This is the heat we're adding is 109 kilojoules per mole of our calcium hydroxide. Now, since we're adding heat into our system, that means we're dealing with an endothermic reaction, because we have to add heat to our system to make it work. We're not producing heat. So our delta H, 109 kilojoules. Now we're going to look at an enthalpy diagram. So we're going to look at time, which is going to be over the course of the reaction. And then we're going to have H over here. So here we have, I'm just going to call this product, just going to call this as A, and I'm going to call this side, I'm going to call this B, and I'm going to call this C. So we're going to, this is our enthalpy diagram. This is our activation energy hump, and we're going from our reactants to our products. So we have A here, and we're going to be converting it to B and C. Now you can know what the delta H is by just subtracting the energy level here minus the energy level here. Remember Hess's law, delta H for your reaction is equal to that's your final enthalpy minus your initial enthalpy. Okay, so it's going to be 109 kilojoules. And that's how we solve this kind of problem. It's very easy once you understand how Hess's law works and the relationship between heat and S and enthalpy. In this case, Q is going to equal your delta H.